What's up? I'm Vin, and today I want to go through the STAAR Grade 4 math test from May 2022. I'll leave a link to a copy of this test in the description below. So let's get started. So question 1, we have John put a pie in the oven at 5:15 p.m. and he took the pie out 35 minutes later. At what time did John take the pie out of the oven? So what time is what we're looking for? So it's 5:15 p.m. So I'm just going to focus on the minutes here. We're at 15 minutes. 35 minutes goes by. So I'm going to add 35, and then 5 plus 5 is 10. So we write our 0, we carry the 1, and 1 plus 1 plus 3 is 5. So this tells us that John took the pie out of the oven at 5:50 p.m. So this is just from us adding 35 minutes to the 15 minutes here, that he takes the pie out at 5:50 p.m. If you want to see this another way, what you could imagine here is just think of a clock. So here are the significant values over here, and it's 5:15 p.m. So that means the minute hand is facing to the right here at the 3. And if 35 minutes goes by, that's the same thing as going 30 plus another 5. So if I want to go 30 minutes, the minute hand is going to go completely to the opposite side here facing the 9. So that's 30 minutes going by. But then an additional 5 minutes would be the result of us. If we look at these numbers here, we have 10, 11, and 12, and each space represents 5 minutes. So we go 30 minutes plus another 5 minutes. The minute hand would be facing the 10. And just know if you want the minute, you just multiply this by 5. So that is another way of us seeing that it's going to be 5:50 p.m. This is a more visual solution, but this is definitely the fastest way to get there. Either way, choice C is our answer. So for question 2, we have to know how to take the verbal representation of a number and turn it into the numerical representation. So we have a town had 3 14/100 inches of rain. So that we could write as 3.14 like this. It had this much rain during June. What is the value of the digit in the tenths place? So the tenths place is over here. Immediately to the right of the decimal is the tenths place. And right after that would be the hundredths place. If we had to go even one more out, that would be the thousandths place. So when they ask us what is the value of the digit in the tenths place, well, this is 1/10. So 1/10 I could express like this, or I could write it as a decimal. This is 0.10 or just 0.1. And this is going to match up with choice J. So question 3, we have an art teacher ordered 26 marker sets for his classes, and there are 100 markers in each set. How many markers are there in the 26 sets? So you have to just think about this very carefully. So each set has 100 markers. So if there are 26 sets total, so what you want to imagine here is that we have a set of markers. There's 100 in this set, there's 100 in the next set, and there's 26 sets total. So what are we doing here? You could think of this as 100 plus 100 plus itself 26 times, or repeated addition is the same thing as multiplication, that we could do 100 times 26. And a nice little shortcut to this, if you don't want to use a calculator, I just think here of these few multiplication facts, that 26 times 1 is 26. If I did 26 times 10, it's the same thing as doing 26 times 1, but putting a 0 at the end. So 26 times 100 would be the same idea, except it's going to be 26 times 1, which is 26, but now with 2 zeros at the end, and we're going to get choice C. Now for this, be very careful, okay? For choice D, this is a very dangerous bear trap. Some students are going to make the mistake of looking at this and just saying, oh, I think I know how to get the answer. They're going to take 100 and they're going to just add 26 like this and get 126, but be careful, okay? Choice D is a very dangerous bear trap. You want to make sure you read carefully that the idea is multiplication. We have repeated addition, which is a multiplication concept. Choice C is our answer. So question 4, we have this drawing and we want to know, what does the drawing show? And for this, we're going to be between line segments and lines. Just know the difference between a line segment and a line is that a line has an arrow at the end because it's implied that the line is going to go on forever in either direction. But a line segment has points at the end, which tells us that it's going to end. It's going to take up just a limited space like this. So right away, I could see that we're not looking at lines, we're looking at line segments. And now the next thing here that distinguishes the answer choices is that we're looking at either parallel lines or perpendicular lines. Well, perpendicular lines or line segments. Perpendicular line segments would form kind of like a letter T here, or a plus sign, and they form 90-degree angles like this, okay, which we show with this box symbol like this. So perpendicular lines intersect, whereas parallel lines are never going to intersect. They face the same direction like this. Now, sometimes you could put this symbol on here to show that the segments are parallel, but what we're looking at here is we're looking at two line segments that appear to be parallel. So question 5, we have a store selling bags of potato chips, and we've got barbecue chips, cheese flavored chips, and plain chips. Which statement is true? And all of these statements are talking about plain chips. So what our goal is going to be here is to come up with the fraction for plain chips, because we know that the rest of the bags are plain chips. So the idea for this is we want to be thinking of common denominators. And what we're going to think about here is look at the denominators we have so far. We have 3 and we have 5. So if we find the least common multiple between both of those, and we could get that by saying the times tables for 5. We have 5, 10, 15, 20, and so on like this. And if I count by threes, I have 3, 6, 9, 12. Eventually I get to 15. So that is the least common multiple between 3 and 5. So that's going to be what we target here. I'm going to do 1 over 3. And I'm going to be multiplying this by 5 over 5 because I want a denominator of 15. So my denominator is 15, and then my numerator would be 1 times 5, which is 5. Now for the next fraction here, 3 over 5. This one I would multiply by 3 over 3, and that gives me a matching denominator of 15, and then 3 times 3 is 9. So now what we're going to do is let's add these fractions together. We have 5 over 15 plus 9 over 15, and for this, just add the numerators. We have 5 plus 9 is equal to 14, and we're over 15 like this. So this tells us that between the barbecue and the cheese flavored chips, that's 14 out of the 15 bags of chips. So that's a pretty big fraction here. So the remaining fraction that would make one whole, because the rest, see here, this is the key phrase, the rest of the bags are plain. The missing fraction here to make one whole would be 1 out of 15. Because if I did plus 1 out of 15, if we just show that over here, plus 1 out of 15 would make 15 out of 15, and that would give us one whole like this. So that would account for all the potato chips. So now we're ready to answer this question. So statement A, more than 1/2 of the bags are plain chips. Well, think about it. If the plain chips, 1/15 of the bags are plain, this is not more than 1/2. 1 over 15, if you just visualize this, is a very skinny fraction. If you think of a pizza comes with 8 slices. If your pizza was cut into 15 slices, they would be very, very small. And one of those slices would definitely not equal half the pie. So this one is out. There are no bags of plain chips. That's not true. 1 out of 15 of the bags are plain. Exactly 1/2 are plain. That's not it. So just by process of elimination, it has to be D, but less than 1/2 of the bags are plain. That is definitely true because 1 over 15 is definitely less than 1/2. This we could say for sure is less than 1/2. So question 6, we have a list showing the number of books donated to a library on 14 days, and the librarian made a frequency table to show the data, and the frequency table is not complete. And we want to know which row of the frequency table is incomplete. So what I would do for something like this is I would make my own frequency table off to the side and then see when I get something that doesn't match the librarian's. So if we look here, we're looking the number of books donated, 0 to 4 books. So let's just look here. We have a 0, which would go here, so we make a mark. We get a 1, so I'd make a mark here. I get a 4, so I make another mark, and then I get another 4, so I make another mark. And notice right away I could see 0 to 4 is the one that the librarian messed up. But to be safe here, what I would do is I would look at the other rows. So 5 to 9, notice we have 6, 7, 8, 8, 9, and that's 5 notches. So 1, 2, 3, 4, 5, and see that matches this. So this one is definitely done correctly. 10 to 14, we would have, I'll change colors here. We have 12, 12, so that's just 2. So those are the only numbers between 10 and 14 in the table. And that matches what we have here. And now I'll switch back to green. So for the last one, 15 to 19, there's 16, 16, 17. That's 3 values here, and that is recorded correctly. So 0 to 4 is definitely the mistake. So this is our answer choice. So question 7, we have 2 hiking trails in a park. Trail Y is 2.7 miles long and Trail Z is 5.84 miles long. What is the total length of these 2 hiking trails? And we're just going to show the work off to the side here. But for this, if we want to know the total length, we just have to add these 2 numbers together. okay? Because you could just imagine it. If we had someone walking along trail Y, so here's trail Y, and it's 2.7 miles long. So they go from here to here, and then a moment later they go to trail Z, and this is 5.84 miles long. You could see here that what they're doing is they're walking this trail plus they're going this trail. So that's why we're adding these two together. So we're going to have 5.84 plus we have 2.7, and 0 we could just put here as a placeholder so we could do the long addition. So I'm doing 4 plus 0 is 4, 8 plus 7 is 15, and I carry the 1. The decimal is just going to carry down like this. And we got 1 plus 5 plus 2 is 8. So our solution here, what is the total length of the two hiking trails? I'll write this off to the side, is going to be 8.54 miles. So here's our solution to question 7. So question 8, we have angle SRT has a measure of 35 degrees, and then we have angle TRV has a measure of 65 degrees, and we want to know here, what is the measure of angle SRV? So for this one, we have to know how to label an angle for one. And for this, let's say angle SRT. What I do is I imagine, how would I draw out angle SRT? I would start at S, and then I would go over here to vertex R, and then I would go up here to point T in this space over here. So this angle that I just built, that's where my 35 degrees is going. And then if I look at the angle in red here, angle TRV, I'm starting at T, I'm going down to R, and then I'm going up to V like this. And you see the angle I just drew, that's the angle that I'm labeling as 65 degrees. So now to answer the question, what is the measure of angle SRV like this? That's this entire angle that I'm drawing in green right now. So to find this entire angle, I would have to add those two angles together. So I'm going to do 35 degrees plus we have 65 degrees. So this, the answer in degrees, we have 5 plus 5 is 10, and I carry the 1, and then 1 plus 3 plus 6 is 10. So our solution here is going to be 100 degrees, choice J. For question 9, we need number sense. So we have this number line here going from 7 to 9 with a ton of spaces in between. We want to know which number does point J represent. Well, right away what's jumping out at me is I see that there's bold lines for the whole number. So we have 7, 9, and then here's the next bold line. So first I would count the spaces, and notice I'm going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 spaces to get to the next number, which is 8. So that tells me if I'm counting by tens to get from 7 to 8, well, think about it. The distance from 7 to 8, those are 1 unit away from each other, one number away, but I'm dividing that by 10. So that means I'm counting by 1/10, which is 0.1. So if I count by 0.1s, I'm going to do 7 plus 0.1. That would be 7.1. And then the next number, and I'll alternate here. This will be 7.2, this will be 7.3, and so on like this. So this is the pattern that we're going to be following here to get from one number to the next. And you could even see here, we're at 7.7, then we're going to be at 7.8, 7.9, and that brings us right to 8, which you could think of as 8.0. It's almost like saying 76, 77, 78, 79, 80, but just having a decimal in the middle. But that's the idea. So now we're continuing this pattern, because notice we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces from 8 to 9. So it's following that same pattern that we're counting by 0.1. So the next number would be 8.1, and then the value of J would be 8.2. So this is going to be our value for J. Choice B is our solution. So question 10, we have a rectangle has a perimeter of 40 centimeters and an area of 64 square centimeters. Which model could represent this rectangle? So for one, we have to know that the perimeter of a rectangle is 2 times the length plus 2 times the width, and the area of a rectangle is length times width. So this is going to come in handy when we want to actually verify that our answer is correct. So for this, the thing that I would look for right away is which answer choices can I throw away? And right away I could see J is not our answer choice, because in my head what I'm doing is I'm looking at the length and the width, and I'm doing 11 times 9 is 99, which is more than 64. So I know this answer choice is no good. When I multiply all these other numbers in my head though, I get 64. So that tells me I have to verify the perimeters here and see. Well, one thing that jumps out at me also right away is that choice G is a square. And if I want to find the perimeter of a square, just know you could take one of the side lengths and just multiply it by 4. You could still use this formula, but it's much faster to just take one of the side lengths, like 8 centimeters, and multiply it by 4, and that would tell you the perimeter is 32 centimeters, which is not equal to 40 centimeters. So I know choice G is out. So now it's between these two answer choices. And just looking at this right away, I could see F is not looking good. Because one thing you have to know about a rectangle is that opposite sides are equal in measure. So right away, when I'm looking at this, if you could add numbers in your head very quickly, you could eliminate this answer choice. When I'm doing 32 plus 32, and then I add 2 plus 2, if I just add these two numbers, I'm already at 64, which is more than the perimeter, which is 40 centimeters. So if two of the sides give me 64 centimeters, then the other two sides are definitely going to put us over 40 centimeters. So that's why I know this one's out, and it has to be H. But if I want to verify here that H is good, we could say, let's say that this is the length and that this is the width. And if I want to verify with the formula, I would say the perimeter is equal to 2 times 16 centimeters plus we would have 2 times the width is 4 centimeters like this. And if we work this out, 2 times 16 is going to give us 32. And we just tack on the centimeters, and then 2 times 4 gives us 8. And now we have 32 centimeters plus 8 centimeters is 40 centimeters, which is the perimeter that we wanted. And if we want to verify the area, we're just doing, so area equals is a little bit sloppy. Let's just fix that up. We have 16 centimeters times 4 centimeters. And this would give us, we would have 64 square centimeters like this. So this answer choice is definitely looking good. Question 11, we have 4th grade classes at a school made flowers to decorate the cafeteria, and there are 5 4th grade classes at this school. To make each flower, 4 sheets of paper were used, and the classes used a total of 300 sheets of paper. Each class made the same number of flowers, and what we want to find here is how many flowers did each 4th grade class make. So for this, there's a lot of information going on, but what we could find out is, first, how many flowers were actually made. So what we have here is that there was a total of 300 sheets of paper used. However, 4 sheets are needed to make 1 flower. So if we take the 300 total sheets that were used and we divide it by 4, that'll tell us how many flowers were actually made. So 4 goes into 30 7 times. 7 times 4 is 28, so we subtract. Remainder 2, carry down the 0. 4 goes into 20 evenly 5 times. 5 times 4 is 20. When you subtract, you get no remainder. This is a very evil answer choice, okay? This is another bear trap. This one we have to be very careful because this tells us that there are 75 flowers in total, okay? So there are 75 flowers in total here, but what we know is that each class made the same number of flowers. How many flowers did each class make? So now what we need to do here is we need to take the 75 flowers now and we need to divide it by 5 because there were 5 classes involved. So if we do this, we have 5 goes into 7 one time. 1 times 5 is 5. Subtract, you get a 2. Carry down the 5, and 5 goes into 25 5 times evenly. 5 times 5 is 25. When we subtract, we get no remainder. So that means each class made 15 flowers. And if you want to just double check that even on the side, you could just visualize it. 15 plus 15, if you add that to itself 5 times, where this just represents all the classes here, this is going to give you, okay, this is going to give you the 75 total flowers like this. So we do 5 plus 5 plus 5 is going to be 25, carry the 2, and then 2 plus 1, we have 3, 4, 5, 6, 7, 75 total flowers. So each class made 15 flowers. Choice B is our answer. Question 12, we have Trina living in an apartment, and the table shows her expenses for 3 months. And what we want to know is which expenses were variable expenses for Trina during these 3 months. So just know variable expenses means expenses that change, okay, that they are not constant. So looking at the rent is $1,500, $1,500, $1,500. That's pretty constant. That is not changing. Okay, so that is not a variable expense. You look at the water bill, $32, $67, $28. So there's the change. You see, there's the change here. At least it got cheaper, but then it got more expensive again. So, oh no. All right, so this is one of the variable expenses. Electricity, variable expense, because notice it was $118.92 and then it changed. Okay, it went down and it went down again. So this was a variable expense. The cable TV bill did not change, okay? $78.75 straight across. So water and electricity only, choice F. So question 13, we have 4 people are mowing their lawns, and the table shows the fraction of each lawn that has already been mowed by each person. And which of these people has mowed greater than 3/4 of their lawn? So for this, what I like to do is there's a nice little shortcut. When you want to compare fractions to see which one's greater, you write the fractions next to each other, but what you do is you multiply across like this. So I do 15 times 3 is 45. And then I'm doing 4 times 10 is 40. And I say, all right, who wins this battle? 45 or 40? And I look at this and say, oh wait, this one wins the battle. So 3/4 is greater than 10 over 15. So Nate is out because we want to know which of these people have mowed greater than 3/4 of their lawn. So we want to see which of these people could beat 3/4. So if we look at the next one here, 5 over 6. I already know 5 over 6 is more than 3/4, but just to show this cool trick, 6 times 3 is 18. So it's 18 versus 4 times 5 is 20, and 20 wins that battle. So 5 over 6 is the greater fraction. It's greater than 3/4. So Rudy is one of the winners here. Okay, and now we're going to write our 3/4 all over again. So we have 3/4, and I'll just write it for the last two as well. So what we have here, if we look at these last two, well, we got 18 times 3 versus 4 times 12. Well, 4 times 12 is going to give us, we're going to have 48. And then 18 times 3, I want to say 54, but if I had to double check, okay, so there's no shame in checking here. This does work out to 54. Okay, so you could use a little mental math or just do the long multiplication on the side. But there is another way to do this. 3/4 wins the battle here, so Mark is out. What we could have also done is said 12 over 18, divide the top and bottom by 6. And if we divide the top and bottom by 6, 12 divided by 6 is 2. 18 divided by 6 is 3. This reduces to 2/3. So we could have also said 2/3 versus 3/4. But the reduced fraction is also going to lose. 3 times 3 is 9. 4 times 2 is 8. 3/4 is still the winner. So Mark is out. And now when you look at these, well, right away I could do divide the top and bottom by 2. And that'll tell me that these are actually equal to each other. Okay, because 6 divided by 2 is going to give us 3. And 8 divided by 2 is going to give us 4. But if we did that battle that we just showed before, 8 times 3 is 24, 4 times 6 is also 24, so it's a tie. So it's exactly equal to 3/4, but which of these people mowed greater than 3/4? Rudy is the only one, so choice C. Question 14, Erin has 12 pictures from a field trip and some pictures from a vacation. She has twice as many pictures from the vacation as she does from the field trip. Which strip diagram represents P, the total number of pictures Erin has? So for this one, I would just label over here, we have the field trip, which I'll abbreviate, that there are 12 pictures. And then there's a vacation. So for the vacation, read this very carefully. She has twice as many pictures from the vacation as from the field trip. So if she has 12 pictures from the field trip, if we want to multiply that by 2, 12 times 2 tells us that Erin has 24 vacation trips. So this is just going to be useful information to have here. So now we look for our strip diagram, and what we need is we need a combination of 12 and 24. So right away I can see that choice F is going to be our solution because the 12 here represents the field trip pictures. The 24 represents the vacation pictures, and that's going to equal the total number of pictures P. This one's no good. This would be if they said that Erin has half as many pictures from the vacation as she does from the field trip. So that's why G is out. H would be if Erin had equal amount from the field trip and the vacation. And then this one here is just if she had 2 pictures from the vacation. So this one's going to be out. Definitely choice F. So question 15, if you just know how to convert this fraction to a decimal and you just know that this is 1.8, then awesome. Otherwise, if you want to see a more elaborate solution here, you could always expand 18 over 10 as 10 over 10 plus 8 over 10. And just know that 10 divided by 10 is 1 and 8/10 is 0.8. So now we're adding 1 plus 0.8, and this is going to be equal to 1.8. So here's our solution to 15. So question 16, we have a table showing the number of miles a family will travel next summer, and we want to know which is the best estimate of the combined number of miles this family will travel next summer. So here what I would do is just round all of these to the nearest 10. And what we have here is, let's say I round to 81. 81 is going to round to 80 because it's closer to 80 than it is to 90. 129 would round to 130. This would round to 180. So I'm just going to keep rounding these. This is already rounded for us. And then 288, I could round to 290 like this. And then 78 is closer to 80 than it is to 70. So now I'm just going to add these up. I'm adding a bunch of zeros, so that's easy. And now I just got to know how to add very carefully here. So I have 8 plus 3 is 11, plus 8 is 19. Now I have 20, plus 9 is 29, and 29 plus 8 is going to give us 37. So I'm going to carry the 3 here to the hundreds place. I have 3 plus 1 is 4. Then we get 5. 6 plus 2 is 8. So 870 miles. And looking at this here, it looks like maybe they rounded to the nearest hundredths place. But either way, 870 is going to be closer to 900. So choice G is our solution. Now, if you want to get the answer more directly, it looks like everything was rounded to the nearest 100. So here, 81 would round to 100 because it's closer to 100 than it is to 0. 129 would round down to 100. 181 would round up to 200, and then we would have 100. 288 would round to 300, and then 78 would round to 100. And now if you add these values together, we get 2 rows of zeros, or 2 columns of zeros. So we get 0, 0, but now we just got to add carefully. We got 1 plus 1 is 2, plus 2 is 4, plus 1 is 5, 5 plus 3 is 8, plus 1 is 9. So there is 900 yet again. But I felt safer here rounding to the nearest 10. It's more accurate. And then 870 is closer to 900 than it is to 700. So either way, choice G is our solution. Question 17, Dion sorted figures into groups, and the figures shown here were sorted into the same group. Which statement best describes the figures in this group? So for this, we have to know vocabulary, and we're going to use process of elimination. So choice A, each figure has only one obtuse angle. Well, look at this over here. We have a square, and all the angles in a square are right angles. They're all 90 degrees. So this one doesn't have any obtuse angles. So choice A is out. Choice B, each figure has at least one acute angle. Well, once again, the square has no acute angles. It only has right angles. So choice B is out. And then we have each figure has only one pair of parallel sides. Well, once again, the square has 2 pairs of parallel sides. So that eliminates choice C. So that square on its own just destroyed choices A, B, and C. So choice D has to be our answer, but let's see why it's true. Each figure has at least one pair of perpendicular sides. Well, here's our perpendicular sides over here. So in the square, there's one pair of perpendicular sides that's making a right angle. In this trapezoid over here, notice that we have a right angle over here. So there's a pair of perpendicular sides. And then this triangle here is a right triangle. So there's one pair of perpendicular sides. So choice D is definitely our solution. So question 18, the blank model shown can be shaded to represent 7/10. And we want to know which expression does not, in bold, show a way to represent 7/10 as a sum of fractions. So basically we have to just add these up and see which one does not equal 7/10. So here 2 plus 2 plus 2 plus 1 is definitely 7. And remember, you keep your denominators the same. So 7/10 is not what we want. We want something that's not equal to 7/10. So choice F is out. And now for this one here, look what we have. We have 4 plus 3 is 7 plus another 3 is 10. And then 10 out of 10 is equal to 1 whole. So this is already looking like our answer, but let's see why the other answers are no good. Well, 6 plus 1 is 7, and we're out of 10 here. And then we have 1 plus 1 plus 1. So let's just count 1, 2, 3, 4, 5, 6, 7. So this is another way to see 7/10. So choice G is our solution. Question 19, we have the models represent the price for a pound of grapes at 4 different stores, and each model is shaded to represent a price that is greater than $1. So which stores have a price greater than $1.60 but less than $1.90 for a pound of grapes? So one thing I'm noticing right away is that we have a 10 by 10 here making 100 squares, and each of those squares represents 1 cent. So right away for store L, I would just find the total price here, that we have $1 here, but then we're going to count by tens. We have 10, 20, 30, 40, 50, 60, 70, 80. And then we have 2 missing to make another 10. So that would be 88 cents. So in total, we would have $1.88 for a pound of grapes at store L. Now ask yourself, is this more than $1.60 but less than $1.90? Definitely. So store L has to be part of our solution here. So choice D is out because that says none of the stores. Now, looking right away here at store M, I can see that store M is out. And the reason being is that we have $1. So we have $1 here plus this looks like 7 cents because only 7 squares are highlighted. So the total cost of grapes at this store would be $1.07, but we need it to be more than $1.60 and less than $1.90. And this is not more than $1.60. So that's why M is out. And that eliminates choice B. And now looking at store N, I can see here we have $1. And then I'm going to count by tens. We have 10, 20, 30, 40, 50, 60, 70. And then it looks like we're missing 2. So we have 78. So this is representing 78 cents. And if we add $1 plus 78, this would be $1.78. And let's ask ourselves, is this more than $1.60 but less than $1.90? Definitely. So N is in the mix. We have L and N. So now we just have to verify, what about store P? And this one should be easy to look at here. Notice it has all but one shaded. So this would be $1.99. Okay, so we have $1.99 here, and this is more than $1.90. So store P is out. So it would just be store L and store N only. Choice C is our solution. Question 20, Lori started to draw an array to help her solve a math problem. She drew one full row and one full column of the array is shown, and she finished drawing the array correctly. Which equation represents a problem Lori could solve using this array? So what I'm thinking of for this question reminds me of finding the area of a rectangle. So if you wanted to find the area of a rectangle, let's say it was a 3x2, what I imagine here is that you're essentially finding how many individual squares make up the entire area. Except in this case, we have circles, but it's the same concept. So what we need to know is how many circles are we going down and how many circles are we going across. So we're going down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we're going down 13 and we're going across 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So essentially what we're finding here, the problem that Lori could solve would be multiplying 14 times 13. And 14 times 13, looking at the answer choices here, there's only one answer choice that involves 13 and 14. So the product of 13 and 14 is 182. If we wanted to find this ourselves, we could do 3 times 4 is 12, carry the 1, 3 times 1 is 3, plus 1 is 4, and then just multiply out the rest. We'll put a placeholder, 1 times 4 is 4, and 1 times 1 is 1. And if we add this up here, notice we get 182. So this answer choice here is our solution. So question 21, we have a table showing the number of feet and the equivalent number of inches. Lionel painted a wall that is 12 feet long. How many inches long is the wall that Lionel painted? So for this one, what you could know is that 1 foot is equal to 12 inches. So if you want to know how many inches there are in 12 feet, you could just do 12 times 12 on the side. So this, if you work this out, this may be one of the times tables that you just have memorized, is 144. So you can see right away that it's choice A. But now let's say you didn't know to do this and you want to solve this a different way. Well, what you could do is you could build 12 feet with the table they gave you. So you could do something like 10 feet plus 5 feet. And then you could subtract. So far we have 10 plus 5 is 15. Then you could subtract 3 feet. And this would give you 12 feet. But then you could just make the substitutions here. Notice that 10 feet, they told us, was 120 inches. Plus 5 feet was 60 inches. Minus 3 feet was 36 inches. So this, if you wanted to work this out, notice 120 plus 60, maybe you could do that in your head, is just 180. And now you're subtracting 36. So if you do this, now we're just going to have to borrow. We're going to borrow. We have 10 minus 6 is 4. 7 minus 3 is 4. And we carry down the 1 here. That this would equal 144 inches. So this is just a slick way of using the table to get the answer of choice A. But once again, the direct flight here would be to just take this known information, 1 foot is 12 inches, and then just say, all right, well, 12 feet would be 12 times 12 inches. So 144 inches would be our solution. So question 22, we have Miss Panvini gave her students a test with 20 math problems, and the table shows the fraction of correct answers for each of the 5 students who finished the test first. So here are the fractions. Which comparison is true? Well, for one, these symbols here all say less than. But what I like to think of is if I write something like this, like 4 versus 5, the symbol would go this way. It would be 4 is less than 5. And the way that I remember this is I think of almost like Pac-Man, if you know that video game, that the Pac-Man would want to eat the bigger number like this. So that's how we're thinking about this. So when we look at choice F is claiming that 4/5 is bigger than 9/10. So we could use that trick I showed before. You could do 10 times 4 is 40, and then you have 5 times 9 is 45. And who wins this battle? Well, 45 wins the battle. So that would mean that this is the bigger fraction, that 9/10 is bigger. So the Pac-Man would want to be eating the bigger fraction, not the smaller one. So choice F is out. So now let's continue on here. So if we multiplied 20 times 9 is 180. I'm just doing 2 times 9 is 18 and then putting a 0. And if I do 17 times 10, that's 170. So looking at this, the symbol was pointing this way. 180 is bigger. So right away, I could see that the fraction ordering here is definitely correct. 17 over 20 is definitely less than 9/10. So choice G is our solution. But let's see why the other answer choices are no good. If we did 10 times 3, we would get 30. If we did 4 times 9, we would get 36. And 36 would win, so 9/10 would be greater than 3/4. And then this one, you might just be able to reason it out here. That 1/2 is definitely not bigger than 17 over 20 because 10 over 20 would be a half. So 17 over 20 is greater than a half, not less than a half. So this answer choice here is out. So choice G is definitely our solution. So question 23, we have there were 3 quarts of water in a container in a science classroom. A student poured 1 quart and 3 cups of water into the sink. And we want to know what amount of water in quarts and cups is left in the container after the student poured some water into the sink. So here, what I think of for this is we have 3 quarts to start. So here's the 3 quarts. And right away, I could see that the student poured at least 1 quart out. So this is going to be gone. 1 quart is gone, but we still have to account for the 3 cups that the student poured out. So now we use the reference page here. 1 quart is equal to 2 pints, and 1 pint is equal to 2 cups. So what I would be thinking about here is that we have 1 quart left, and then the second quart, I'm going to break this up into 2 pints. But then I'm going to break this up even further. Okay, I'm going to break this down. We have 1 pint is equal to 2 cups. So I'm going to have 1 quart, and then each of those pints I could break down into 2 cups each. So now we think about the rest. The student poured out 3 cups. So now I'm just going to cross off 3 more cups like this, because notice I already crossed off 1 quart, but I didn't cross off the 3 cups left. I did that after we converted everything. So how much do we have left? Well, there's 1 quart left. So this over here, we have 1 quart and 1 cup left. So we just have to scan the answer choices. Choice D is going to be our solution. So question 24, we have a gardener planted 24 bushes in 4 rows, and all of the bushes were either rose bushes or lilac bushes. And the shaded parts of the model represent lilac bushes. So for this one, what I'm going to do is I'm going to label the shaded stuff with an L because they told us the shaded stuff represents the lilac bushes. So I'm just going to go ahead and label all of these like this. And now we're ready to answer this question. What we want to know is which equation shows how to find the fraction of the bushes that are lilac bushes. Well, think about it here. There are 28 bushes in total. So each of these little squares is 1 out of 28 of all of the squares here. So we have to just think about if we go row by row. Notice in the first row there was 1, 2, 3, 4 lilac bushes. So that's 4 out of 28 plus. Then there were 3 lilac bushes in the second row. So that's 3 out of the 28 total. Plus then there was another 3 out of the 28 total. And then there's 5 in the last row. So now we just have to scan the answer choices here. And which one has this corresponding sum? 4 plus 3 plus 3 plus 5 all over 28. And this is matching up with choice F. Question 25, we have Yolanda wrote a number, and we have digits in the millions, thousandths, and hundredths place. So this is a pretty big number here. So I'm just going to go ahead and make spaces. So we have the ones, tens, hundreds, and then we have the thousands, 10,000s, 100,000s, and then finally the biggest place we're looking at is the millions place. But then we have a decimal, and we're going all the way out to the hundredths place, which is 2 spaces after the decimal like this. So now we just write in the stuff that we need. The digit in the millions place is an 8. So that would be over here. The 8 is going to be all the way at the end like this. So this would be the millions place. And then the digit in the thousandths place is a 6. But be mindful here, it's the thousands place. So that's to the left of the decimal. Thousandths with a TH would be a 3rd digit out here after the decimal. And then we have the digit in the hundredths place is a 2. So now we just have to look through the answer choices here and see which of these numbers, and notice that these are all numbers that have a 10 millions place. So whatever's going on over here, like essentially doesn't matter. What we need is we need an 8 in the millions place. So A is out because the 8 is to the left here. It should be where the 5 is. So that one's out. This is a contender. So we could leave this in the mix, and we could leave this in the mix. And we could also leave choice D in the mix because they all have an 8 in the millions place. But now the next place to look would be the thousands place. So if we look here, we have a 6, and a 4. So choice D is out because this should be a 6 if it wants to stay in the mix. Didn't mean to rhyme there. Okay, so let's keep going. Now we have the digit in the hundreds place is a 2. And we can see here that B is out because we have the tenths place is a 2. The hundredths place is a 1. Choice C is definitely our solution. So question 26, we have a list showing the number of points a basketball team scored during the games the team played last season. So here's all their points. And then the stem and leaf plot shows this data. So just so you know, the stem represents the tens place, and then the leaf represents the ones place. So something like 9/8 like this means 98 points. So this is just another way of organizing data. And what we have to do here is we have to fill in the blank. What number goes in the blank to complete the stem and leaf plot? Well, let's think about this. This row here is all the numbers that are in the 90s. So if we look, we have 98, we have 95, we have 98 again, and we have 92. But notice that 95 is accounted for. See, we have a stem of 9 and a leaf of 5. We have 98 accounted for twice. So we have a stem of 9 and the leaf is 8. And then we have a second leaf that has an 8. So that accounts for the other 98. So the only number in the 90s that was not accounted for was 92. So that means the missing leaf is going to be 2. So what number goes in the blank to complete the stem and leaf plot? 2 is going to be the number that goes in the blank. That's our solution to 26. Question 27, we have to know how to read a protractor. We have angle TUV over here, and we want to know what is the measure of angle TUV to the nearest degree. So there's a few ways you could go forward with this, but one way is to look at this number here where the first ray hits is at the 10 degree mark. Okay, so that's where the first ray hits, and then the second ray is hitting at 70 degrees. So what we could do is just see how many degrees are between 10 and 70 degrees. We could do 70 minus 10 like this, and that would tell us the measure of the angle is 60 degrees. Now, another way to do this would be to focus on the other numbers. Notice that we're going from, and we'll change colors here, we're going from 110 degrees on this ray to we have 170 degrees on the second ray. And if we subtract those two angles, 170 minus 110 is still going to give us 60 degrees. So either way, choice B is our solution. Question 28, on Thursday, 50 books were returned to the library. On Friday, 4 times as many books were returned than were returned on Thursday. So what I would do first is just write, we have Thursday, we have 50 books returned. On Friday, 4 times as many. So just do that math in your head or off to the side. 50 times 4 would give us 200. So 200 books were returned on Friday. And now let's look at the question. Which set of equations can be used to find B, the total number of books returned to the library on these 2 days? Well, just think about the math that I did on the side. I did 50 times 4 to see how many books were returned on Friday. So I'm scanning the answer choices, and right away I see 50 times 4 only shows up in choices H and J. So that's why these two answer choices, I could tell right away, are going to be out, because these are essentially saying that the same number of books were returned on Friday than were returned on Thursday. So that's why these choices are no good. But then let's think about it. How do we find out the total number of books that were returned? We would have to add these books together. So we would say that 200 plus 50 books were returned. 250 books in total were returned. So that would be equal to the value of B. So looking at the answer choices, we can see choice J is our answer because this answer choice, we are adding 250. H is no good because multiplying would be way too much. So choice J is our solution. Question 29, which of these statements describe the primary services of a bank? So statement 1, customers can borrow money from a bank. This one is definitely true. If you have to buy a house, most people can't afford to buy a house all at once unless they're mega rich. Most people are going to borrow money to buy a house, and the bank is going to give them that money. You're going to have to pay that money back, but the bank will let you borrow money to buy a house. And now the second statement, customers can put money into a savings or a checking account. This is also true. Most people don't want to have all of their money sitting at home. They put it in a bank to keep it safe. And if they need money, they go to the bank to take the money out. So statement 2 is also good. Statement 3, customers can pick up packages at a bank. This one, no. This is more along the lines of like an Amazon locker. If people actually have an Amazon locker, or you go to the post office, you go to the UPS store. So statement 3, that is not the purpose of a bank. You go there when you are dealing with money. And now statement 4, customers can cash checks at the bank. Yes, if you want to take money out of the bank, you want to cash a check, you go to the bank. So statements 1, 2, and 4 are valid. They talk about the primary services of a bank. So that tells us choice B is our solution. So question 30, we have a baker is making cakes and it takes 9 eggs to make each cake. And we have the baker has 8 cartons of eggs. Each carton has 12 eggs. what is the greatest number of cakes that the baker can make using these eggs. So what we want to find here is we want to find the total number of eggs. We're going to find the total number of eggs, and then we're going to divide that by 9 because it takes 9 eggs to make each cake. So our first objective here is to find what is the total number of eggs that this baker has. Well, they told us that the baker has 8 cartons of eggs, and each carton contains 12 eggs. So we're going to do 12 times 8 to see how many eggs that the baker has in total. Okay, so what I'm visualizing here is that there's 8 cartons of eggs. So I'm not going to draw all 8, but they all have 12. And if there's 8 of these in total, we're essentially doing 12 plus 12 plus 12. We're doing that 8 times. So if we do 12 times 8, that'll tell us the total number of eggs. And if we have our times tables memorized, this is just going to be 96, or we could do the long multiplication. So here, what we're going to do is we're going to take the total number of eggs, 96, and now we're going to divide it by 9. So how many times does 9 go into 9? It goes into 9 once, evenly. 1 times 9 is 9. We subtract 9, we get 0. We bring down the 6. How many times does 9 go into 6? It goes into 6 0 times, and we have a remainder of 6. So we have 10 and 6/9 like this. So now think about what this means very carefully. What is the greatest number of cakes the baker can make using these eggs? Well, what we just did was we took the total number of eggs and divided it by 9. So the baker can make 10, and if we reduce this, 10 and 6/9 will reduce to 10 and divide the top and bottom by 3, and you'll get 2/3. The baker can make 10 cakes total. We can't make 2/3 of a cake. The baker is not going to make a cake with the piece missing, because then people are going to say, hey, you took a bite out of my cake. So in this case here, the baker can make 10 full cakes, and the fraction of a cake is just not going to count here. So 10 cakes is our solution. Question 31, we have a set of figures shown here. We want to know which figure has at least one acute angle, right angle, and obtuse angle. So looking at this, figure X is jumping out at me right away, because notice we have a right angle here. The obtuse angle is here. That's the angle that's more than 90 degrees. And then we have an acute angle over here in this corner. So this one fits the description. The reason why this figure is no good, so if we look over here at the wrong ones, figure T is no good because we have acute angles here and we have obtuse angles up here. But there is no right angle, so that's why this one's out. Choice A is no good. Choice or figure W here is a 7-sided figure. All of the angles are obtuse. They're all more than 90 degrees. So this figure is out. And then figure Y is a triangle, and this looks like a right angle, and then we have 2 acute angles over here like this. There is no obtuse angle. So that's why this figure is gone. So definitely figure X. Question 32, which mixed number is equivalent to 17.04? So for one, choice F is a very dangerous bear trap. We have to know here that 17 and 4/10 would be equivalent to 17.4 like this. So the 4 to the right of the 0 is different. This is 4 hundredths. Okay, so we have to recognize this as the hundredths place. So this we can convert. We could write this as 17 and 4 hundredths, and this would correspond to choice J. Question 33, we have a rectangular placemat. So I'm just going to go ahead and draw a rectangle. And the placemat is 18 inches long. So it's 18 inches long and it's 12 inches wide. And we want to know what is the area of this placemat in square inches. So just know the area of a rectangle is length times width. So what we're going to do here is I'm going to multiply these numbers. We're going to be doing the area equals, we have 18 inches times we have 12 inches like this. So on the side, I'm just going to do the long multiplication. So we have 18 times 12, and 2 times 8 is 16. I carry the 1. 2 times 1 is 2, plus 1 is 3. And now I put a placeholder. 1 times 8 is 8, and 1 times 1 is 1. So we work this out. We're going to add 6 plus 0. 3 plus 8 is 11. Carry the 1. It is going to work out to 216. So we have 216 square inches like this. And that's going to match up with choice A. So question 34, our last multiple choice question. We have a table showing the relationship between the position of a number in a pattern and its value. And we want to find here which set of expressions shows how to find the value when given the position. The key phrase here is we are finding the value. So looking at this, I could see right away choice H is our solution, because if we plug this in, we have the expression is 1 times 21, and 21 times 1 is definitely 21. If we do 2 times 21, that's going to tell us the value. And we have 2 times 21 is 42. 3 times 21 is definitely 63. And 4 times 21 is definitely 84. If we had to verify any of these, something like 21 times 4, just do 4 times 1 is 4, 4 times 2 is 8. And you can see that these are all checking out. Now, why are these answer choices no good? Well, 21 minus 20 is going to give us 1, but that's not going to tell us the value. That's going to tell us the position. 42 minus 20 is also not going to work out here. If we did 42 minus 20, you can see here, this is going to work out to 22. So that number is not even showing up at all. So choice F is really no good. And then looking at choice G, 1 plus 20 gives us 21, and this gives us 22, 23. And you can see that these numbers aren't even showing up in the value column. So G is out. And now looking in the value column here, 1 times 2 is 2, 2 times 2 is 4, 3 times 2 is 6, 4 times 2 is 8. Once again, these numbers are not showing up in the value column here. So this is our solution.